double integral of x over square root of x square plus y square dy dx, and the limits of y are from 0 to square root of 2x minus x square, and the limits of x are from 0 to 2. So we have to evaluate this integral by changing the Cartesian coordinates to polar coordinates in positive quadrant. Now when you notice here that limits of y are from 0 to square root of 2x minus x square, if I take y to be equal to 2x minus x square, then if I square both the sides, I get y square equal to 2x minus x square. Taking x square to the other side, this is x square plus y square equal to 2x. Now in polar coordinates, we know that x is r cos theta and y is r sin theta. And x square plus y square is r square. So can I write instead of x square plus y square as r square? Yes. So this is equal to 2. For x, I write r cos theta. And from here, I get that r is 2 cos of theta. Right? So for the region of integration, I already know that we have discussed also earlier that the graph for r is equal to a cos theta in the positive quadrant is semicircle like this, where this distance is a. Similarly, I can sketch the graph for r equal to 2 cos theta like this, right? And making a wedge that describes that r is varying from 0 to, this is r equal to 2 cos theta, right? And because it is lying in the first quadrant, so theta is varying from 0 to pi by 2. So integrating this double integral, just writing the limits, replacing x with r cos theta, and square root of x square plus y square is r square. You can also write it as r only here in the denominator. So this is r, and here you just multiply r d theta for polar coordinates, writing the limits for r first, which is from 0 to 2 cos of theta, and the limits for theta are from 0 to pi by 2, right? And here r is also cancelled with this r, so we have left up with, this is from 0 to 2 cos of theta, and this is r cos of theta dr d theta. So to evaluate this innermost integral, we have to integrate this with respect to r. So theta is constant, so this is equal to 0 to pi by 2, and the integration for r is r square by 2, writing cos theta as well, and the limits are from 0 to 2 cos theta d theta, right? So this is equal to 0 to pi by 2, taking 1 by 2 outside, and cos of theta. Alright, putting r as 2 cos theta, I get 4 cos square theta minus, this will be then 0 d theta. So this is equal to 1 by 2, taking 4 outside of the integral. So this is from 0 to pi by 2 cos of cube theta d theta. And if I want to use the reduction formula, the power for cos theta is 3. Just subtract the power with the odd numbers in the numerator. So 3 minus 1, we don't need to write 3 minus 3, that will give you the answer 0. Stop here. Over in the denominator, we just write the power first, and then subtracting the power with the even numbers. So this is 3 minus 2, and 3 minus 4 will give you the negative value, so stop here. And so this is equal to, alright, this is twice 3 minus 1 is 2 over 3, and this is 1, right? This is 2. So finally you get 4/3 as your answer. Thank you.